Assalamu alaikum. Welcome to my YouTube channel. I am Dr. Abrar and today I am going to teach elements, compounds and mixtures and giant covalent structures. So let's start. And before starting, let me remind you, please subscribe my channel and share it with other students. So let's start. First of all, I will focus on elements, compounds and mixtures. I will define them and then we will differentiate the element, compound and mixture, their features, their characteristics. So element. An element is made up of same type of atoms or same type of molecules. For example, iron, its chemical symbol is Fe. It is an element. Similarly, gold is an element. Similarly, copper is an element. So I am giving the example of metallic elements. Now there are some non-metallic elements. For example, oxygen gas is a non-metallic element. Similarly, sulfur, phosphorus, these are elements. The one which you find in the periodic table is the list of elements. So I repeat that element is made of same type of atoms or same type of molecules. This diagram obviously is representing an element. Now look here that all the circles, they are same in size, they are same in color, they are representing, they are showing the same type of atoms. It means that this diagram is representing an element. It can be iron, it can be carbon or something else. So now come to compounds. A compound is made up of two or more than two elements which are combined through a chemical reaction. When they are combined, when two elements or more than two elements, they are combined through a chemical reaction, so they form a compound. And in the compound, the elements are combined by a fixed ratio. For instance, water, if I give the example of water, its formula, as we all know that the formula of water is H2O. So it is showing, this formula is showing that water is a compound and it is made up of two type of elements, hydrogen and oxygen, and these two elements are combined through a chemical reaction in water by a ratio of 2:1 ratio, two atoms of hydrogen and one atom of oxygen. So this is the definition of compound. And now come to mixtures. When various elements or various compounds, they are mixed together just by physical mean, not by chemical mean, just physically, not chemically. When they are mixed by physical mean, so then they form mixtures. For example, air is a mixture. Air is a mixture of nitrogen and oxygen and carbon dioxide and other gases and sometimes water vapors as well. So air is a mixture. Similarly, another common and famous example of mixtures is alloys. For example, what are alloys? That mixture of metals. For example, bronze age we call it. So bronze is a very famous and ancient alloy of copper and tin. So for humans are using this alloy, or making this alloy for centuries ago, bronze. Similarly, brass is another alloy of copper, where copper and zinc is mixed together. Similarly, steel is another alloy. So all these are the examples are mixtures. Alloys are mixtures. Now let me differentiate let me tell you the difference between the among the elements, compound and mixture. One thing keep in mind that element, as I told you initially, is made up of same type of atoms, but when the two elements they are combined through a chemical reaction to form a compound, so then their chemical properties totally change in a compound. How? Let me explain you by an example. For example, water. So here water is made up of two elements, hydrogen and oxygen. Hydrogen and oxygen both are gases at room temperature, but when water is formed, so water is a liquid at room temperature, so the properties are changed. Another thing, hydrogen is a flammable gas which catches fire and it can be used as a fuel, and oxygen helps in burning process. So hydrogen burns and oxygen helps in burning process. But when these two gases combine, so they form water, which is totally different. Water neither burns nor it helps in burning, rather sometimes it stops burning process and it is used to put off the fire. So look at this. When the compounds are formed, so they are totally different from the elements by which they are formed. So they are totally changed. Their properties are totally changed from their elements. Another example is sodium chloride. So sodium chloride is the common salt, where sodium is a metal and chlorine is the non-metal. And sodium is a very explosive metal and chlorine is a very toxic gas. It can be used as a chemical weapon, chlorine. But when these two elements are combined, so they form sodium chloride. Sodium chloride, we eat it. We put it on. We put sodium chloride in our food. It's a food salt. It's neither toxic nor it's explosive. So now you have seen that how the properties are changed. So in compounds, the properties are totally changed. The elements, they change their properties when they form a compound through a chemical reaction. Now I will also explain the compound by this diagram. Now look at this diagram. This diagram is representing suppose a compound. It can be sodium chloride, for instance, where this one, suppose this red one, it is showing sodium and the blue one is showing chlorine. So these two circles or these two atoms, these two circles are representing two elements which are combined through a chemical reaction, and they are combined with a fixed ratio. Suppose in this case they are combined with 1:1 ratio in case of sodium chloride, or so this diagram is showing compound. So in compounds, the elements are combined through a chemical reaction in a fixed ratio, like in case of sodium chloride by 1:1 ratio. In case of water, the compound, two elements of hydrogen and oxygen, they are combined by a 2:1 ratio. Similarly, in carbon dioxide, which is another compound, the elements are combined by 1:2 ratio, 1 carbon and 2 oxygen. So this is about compound. Now come to mixtures. So as I told you earlier, that here the different elements or compounds are just mixed together by physical mean. For instance, this diagram is showing mixture. Maybe that here sodium chloride and this one is showing water, H2O, this one H2O, this is H2O, water molecule. So water molecule, in the water molecule sodium chloride is dissolved and maybe some carbon atoms are there suspended, and maybe some other gases or some other components are mixed. So it is a mixture. This diagram is showing a mixture. Now remember that in mixture, when the elements are mixed together just by physical mean, their properties does not change. Their properties, they they are not changed. Okay, so their properties they remain. Rather, what happens, that mixture, in the mixture the elements whatever we mixed, their properties become an average. In the mixture there is an average of all the you can say elements which are mixed in the mixture, their properties are an average. For example, if we dissolve sugar in water, so water remains liquid in the sugar solution and the sugar remains sweet. The formula of sugar is C12H22O11, for instance, C12H22 sucrose. I am talking about sucrose. So this is sweet. When you will dissolve this sucrose, this sugar in water, so it will remain sweet. It will not change, its taste will not change. However, if you will dissolve more sugar, so it will be, the solution will be more you can say sweet, and if you will add less sugar, so it will be less sweet. So it will be an average and the water will remain same. And if you will add salt, so it will also feel salty. The solution will feel salty. If you are adding sugar in water as well as you are also adding some salt in water, it will remain salty and sweet. Partly it will taste sweet and partly it will feel salty. It will taste salty and it will also show the property of a liquid. So mixtures, I mean to say, they are formed because of the elements and their properties are an average of all the elements through which the mixtures are formed, because they are not formed through a chemical reaction. They are just physically mixed together. Now come to giant covalent molecules. Giant means large. Sometimes they are also called macromolecules. So what about giant covalent molecules? These are, we can define them, that large network of atoms bonded together by covalent bonds. For example, diamond is an example of giant covalent molecule. Similarly, graphite is another example of giant covalent molecule. Another example of the macromolecule or the giant covalent structures is sand. SiO2 is its formula, where diamond is chemically diamond is carbon. Similarly, graphite is chemically carbon, but both are arranged in different atoms through covalent bonds and they are forming giant structures. Diamond is also a macromolecule, a giant structure, giant covalent molecule. Similarly, graphite is also a giant covalent molecule. However, we can say that both graphite and diamond are allotropes of each other. Their arrangement of atoms are different. They can be called allotropes. What are allotropes? Allotropes, for example, diamond and graphite are allotropes of carbon. Both are carbon. Both diamond and graphite are carbon. But both of them are giant covalent structures. Both are macromolecules, but they are arranged differently. One has assumed the shape of diamond and other has taken or has assumed taken the shape of graphite. So this is about giant covalent molecules, and another feature of giant covalent molecules is that despite of the fact that giant covalent molecules or the macromolecules are covalently bonded, but because of the large network of atoms, because of the sometimes millions of atoms are joined together, so that's why they are very stable and they have very high melting and boiling point. because of millions of atoms joined together. As we say, unity is strength. So here giant covalent molecules are very strong and very stable because of this giant structure, because of the macromolecules. Now we will solve some of the questions from past paper from O-level chemistry questions. So question number 1, which is a compound? Air, carbon, oxygen or steam? So remember, steam, it is actually water, its formula is H2O, it is a compound, while air is a mixture, carbon and oxygen are elements. So our option is D. Next question, which statement is not correct? Air is a mixture, ammonia is a compound, methane is a compound or seawater is a compound? So the answer is seawater is a compound. It is wrong. Seawater is a mixture. All the other statements are correct, but option D is wrong. Next, which of the following is not a mixture? Ethanol, petrol, steel and tap water. So ethanol is a compound. Ethanol is not a mixture. While petrol is a mixture, steel is an alloy, it's a mixture, and tap water is a mixture. Option A, 3, option A. Now next, the diagram shows the structure of diamond and graphite. Which property do these substances have in common? So this is option A. They are giant structures. Option A is slightly, it is not showing fully, but I am reading, they are giant structures. So both diamond and graphite are giant structures. They are macromolecules. Question number 5. Which substances has a giant molecular structure at room temperature? Methane, sand, sodium chloride or water? So sand, silicon dioxide, SiO2, as I told in the lecture, it is a macromolecule. It is a giant molecule. While methane and sodium chloride and water, they are not giant covalent structures. So option B. Question number 6. The symbols are representing atoms of different elements. Which diagram shows a mixture? Which diagram shows a mixture of element and compound? So here not A, it is not B, it is C. The diagram C is showing the mixture of elements and compounds. Next, question number 7. For which of the following can graphite be used? Graphite, as I told you, is a giant macromolecule. So it is used as an electrode and it is used as a lubricant. So option C, because graphite, remember, is the only non-metal, it is the only non-metal which is conductor of electricity. So that's why it is used an electrode. And another use of graphite is that it is used as lubricant in engine oils. So this is about the questions, and thank you very much.